Good morning, everyone. It's a pleasure to be with all of you this morning here in Germany. As all of you know, GDP is slowing all over the world, everywhere, every region. And the reason is productivity has been declining for 20 years all over the world. The result, unemployment's high, and especially among the young millennial generation coming of age today. Our economists project 20 more years of slow growth. And here's the final calculus. We've had two industrial revolutions in the 19th and 20th century. Tremendous leap forward for the human race, but here's the bottom line. This morning, the 62 wealthiest human beings on the planet, we could put them right here in this little room, the 62 wealthiest human beings on the planet, their combined wealth now equals the accumulated wealth of 1/2 the human population living on Earth. There's something dysfunctional about the way we're organizing our economic life here on this little planet. And now the economic crisis is compounded by a more profound environmental crisis. In the Industrial Revolution, we dug up massive amounts of carbon from the Carboniferous era to run the industrial way of life. And now the sad reality is we are in real-time climate change on planet Earth. What's terrifying about climate change, it's never explained, is it changes the water cycles of the planet. That's why it is so dramatic. You know, we're the watery planet. We go to other planets with our satellites, we look for water, and if there's no water, we're not interested. Our ecosystems have developed over millions of years on Earth based on the water cycles that traverse the cloud covers. For every 1 degree that the temperature goes up on this planet from industrial-induced CO2 emissions, for every 1 degree that temperature goes up, the atmosphere is sucking up 10%, 7% more precipitation from the ground. The heat is forcing it up there, and that means we're getting more concentrated precipitation in the clouds, more extreme water events, more dramatic winter snows, more dramatic spring flooding, more dramatic summer droughts, more dramatic wildfires and hurricanes and tsunamis and typhoons all across this earth every year on an exponential curve. Our ecosystems cannot catch up to this runaway water cycle. We're heading toward a cataclysm in real time in the next several decades. Our scientists tell us we're in the 6th extinction event right now on this earth. We've had 5 massive extinction events on this planet in 450 million years, well before human beings were ever here. And every time, the chemistry of the planet shifted suddenly in massive die-out. Each time, 10 million years or more to recover biodiversity lost. Our scientists tell us we are now in the 6th extinction event, and if you're parents and grandparents, I want you to listen to this. Between now and the end of the century, we could lose over half the species of life on Earth. That's a wipeout. We have little 2-year-olds who will be my age at the end of the century. They may be facing something that's beyond our ability to even describe. As my wife says, we're not grasping the enormity of this moment. 99.5% of all the species of life that have ever inhabited this earth have come and gone. We're the babies here. Anatomically modern humans, we've only been here about 200,000 years. There's no guarantee we're going to make it through this next period of history. So what do? We have an economic crisis that's compounding every day. That global economic crisis has given rise to climate change, threatening the future viability of life on Earth in our lifetimes. It's clear we need a new economic narrative for the world. It has to be compelling. We need a game plan for that narrative, and it has to be deliverable in both the developing and developed nations. We're going to have to move into a post-carbon ecological era in the next several decades if we have any chance of getting over the divide and into a new journey for our species and our planet. So we have to step back and ask a very important question this morning. How do the great economic revolutions in history occur? If we know how they occur, we can get a roadmap here at Daimler and for all our businesses around the world and for civilization at large as to the new journey that we need to take with the compass that we need to have with us. There have been at least 7 major economic paradigm shifts in history, and they share a common denominator, which is kind of interesting anthropologically. At a certain moment of time, 3 defining technologies emerge and converge to create what we call in engineering a general purpose technology platform, an infrastructure that fundamentally transforms the way we manage, power, and move economic activity. What are those 3 technologies? Number 1, new communication technologies to more efficiently manage our economic activity. Number 2, new sources of energy to more efficiently power our economic activity. And number 3, new modes of transportation and logistics to more efficiently move the economic activity. When communication technologies, new sources of energy, new modes of transportation come together, they fundamentally change the way we manage, power, and move economic life. Let me give you 2 examples. First industrial revolution, 19th century. Communication, energy, transport, manage, power, and move economic activity. Let's go to Britain. The Brits take us into this first industrial revolution with a new communication revolution, steam-powered printing. Big leap forward from manual printing. We could mass produce communication cheap, efficiently to manage our economic activity. And after that, the Brits laid out a telegraph system in the second half of the 19th century. These communication media converged in Britain with a new power, a new source of energy, cheap coal. And then the Brits invented the steam engine to harvest that coal. And then this is what's really ingenious. They put the steam engine on rails, locomotives, national transportation, logistics, large urban centers. The trains connected urban life, a new way of organizing our value chains. 20th century, second industrial revolution, Germany, and even more importantly, the United States. Again, communication, energy, transport, manage power, and move economic life. Centralized electricity, and especially the telephone. You know, we think of the internet as a pretty big deal, but the telephone was a huge leap forward. Instant communication, speed of light across the earth. Later, radio and television. These communication media converged in the United States with cheap new energy, Texas oil. And then we borrowed the German invention by Daimler, the internal combustion engine, a Daimler invention, and Henry Ford put everybody on the road with cars, buses, and trucks. That second industrial revolution took the whole world through the 20th century, and it peaked. July 2008 was the peak. Remember that month. Brent crude oil hit $147 a barrel on world markets in July 2008. And when that happened, the economy of the world shut down that month, collapsed. No economic activity. That was the great economic earthquake that signaled the beginning of a long end game for the second industrial revolution. The collapse of the financial markets 60 days later, that was the aftershock. And the reason is everything in the second industrial revolution is based on carbon. Fertilizers, pesticides, construction materials, most of our pharmaceutical products, synthetic fiber, power, transport, heat, and light. It's an endless list of carbon-based products and services that run our contemporary way of life. So when the price of crude oil starts to go over about 90 a barrel, all the other prices go up. When we get into the zone of 120 to 125 a barrel, purchasing power starts to shut down because of high prices. We are now in a long end game of growth and blowback, growth and blowback. In 2009 and 10, oil went down to 50 a barrel because there was no economic activity. We started to regrow the economy in 2010, and by 2014, we hit another spike at $114 a barrel. Prices went up, purchasing power slowed again. Now this is compounded. because we now have a struggle within the fossil fuel energy at the last stages of this second industrial revolution. OPEC is keeping oil production high to wipe out its competitors, shale gas and tar sands, and it's doing it. It's gone. Shale gas is going bankrupt in the U.S., tar sands is going down, and then those oil prices are going to go back up. This is a long end game. So let me share an anecdote with you. When Chancellor Merkel became Chancellor of Germany, she asked me to come to Berlin in the first few weeks of her new government to help her address the question, how do we grow the German economy and grow jobs on her watch? The first question I asked the new Chancellor when I got to Berlin is, Madam Chancellor, how do you grow the German economy, the European Union economy, or for that matter, the global economy, when your businesses across Germany are plugged into a second industrial revolution infrastructure of centralized communication, fossil fuel nuclear power, internal combustion road, rail, water, and air transport, and the productivity out of that system peaked over 20 years ago. That's the issue. Now, I just mentioned this term productivity. Let's talk about it. There's a dirty little secret in economics that economists do not like to share, so I'm going to take the liberty of sharing it with you. What is the nature of productivity? We used to believe there are two factors that measure productivity: better machines and better workers. But when Robert Solow won the Nobel Prize for economic growth theory in the 1980s, he let the little secret out. He said, when we take a look at every single year of the Industrial Revolution, these two factors, better machines, better workers, only accounts for about 14% of productivity. So Robert Solow asked the big question, where'd the other 86% of productivity come from? Don't know. Now, does that surprise you that economists don't know? It should be basic to their profession. Let me explain why they don't know, because it's critical to talking about what's happening here with Daimler today and the significance of this. When economic theory was penned in the late 1700s, the vogue was Newton's physics, so everyone wanted to borrow Newton's metaphors, including the new economists. So, for example, you know Newton's law, for every action, there's an equal and opposite reaction, Newton's law? Adam Smith borrowed that metaphor to describe the invisible hand of supply and demand. For every action, an equal and opposite reaction. You know Newton's law, a body in motion stays in motion unless disrupted? Baptists say the French economists borrowed that metaphor to say that supply stimulates demand, which generates supply, which stimulates demand unless disrupted. All of our economic theory is based on Newton's physics as metaphor, and there's only one thing wrong with this. Newton's physics has absolutely nothing to do with economics. Nothing. Economics are governed by the same laws that govern the whole universe, govern the solar system, govern our biosphere, govern our economic activity and everything you and I do today. Those are the first and second laws of energy, the laws of thermodynamics. They were discovered by German, European, and American engineers in the late 19th century when they were examining energy flows in machines. Here's the first law of energy that governs the universe. All the energy in the universe today has been here since the beginning of time, the Big Bang, and will be here to the end of time. We don't create or destroy energy. But the second law says, well, that's true, but energy always changes form, but only in one direction. From concentrated, the Big Bang, to dispersed through the galaxies, from hot to cooled off, from available to unavailable. Entropy is a measure of unavailable energy, can't do any work for us. What does this have to do with this morning? There are three types of systems in the universe: open, closed, and isolated. An open system exchanges matter and energy with the outside world. A closed system exchanges energy but doesn't exchange matter with the outside world, and an isolated system doesn't exchange matter or energy. The Earth, in relation to the solar system, is B. We have plenty of energy for the sun, but in terms of the fixed matter on Earth, which is a form of energy, the rare earths, the metallic ore, what we've got is what blew off the sun. We get a few meteorites down here, little cosmic dust, but that's about it. Now, all of you have your smartphones this morning. There are 30 little rare earths in your smartphone. They've been here since we blew off the sun, fixed, a metallic ore. These are forms of energy in a material form. So here's what economics is really all about. We take available energy out of nature on this planet. It can be a rare earth, a metallic ore, a fossil fuel. And then we extract it, we store it, we ship it, we produce goods and services from it, we distribute it, we consume it, we recycle it. At every step of conversion from nature through us and back to nature, we have to embed energy into the product or service to get it to the next stage, but we lose energy in the transformation. This is important. This is called aggregate efficiency. That's the ratio of potential to useful work at every single conversion of every economic activity across our value chains. Let me give you an example of how it works in nature. If a lion chases down an antelope or a gazelle and kills it, only about 10 to 20% of the energy in that antelope is actually embedded into the lion. The rest is lost in the chase, the hunt, and the consumption. That's low aggregate efficiency. What does this have to do with my discussion with the Chancellor of Germany? She's a physicist, and here's what I explain. In the United States, Germany was comparable. We started at around 3% aggregate efficiency in 1905 at the beginning of the Second Industrial Revolution, meaning 97% of every conversion, we lost more energy than was embedded into the product or service. By 1990, the United States got up to 14% aggregate efficiency, and nothing's changed. We've never gone above that ceiling. Germany got up to 18.5% aggregate efficiency in the 1990s. Nothing's changed. Nothing went beyond that ceiling. Japan got to 20% aggregate efficiency in the 1990s. Nothing's changed. We now know, with the younger generation economists who've gone down and back and looked at the record, if you take better machines, better workers, and then aggregate efficiency, that third factor amounts to much of the 85% of productivity. Daimler could have told you that at the beginning of this great company, so could Henry Ford. Every engineer and chemist and biologist and architect understands productivity is the ratio of potential to useful work. It has everything to do with the revolution that you're going to hear about today with Daimler. And on that first day with the Chancellor, I said to her, you can have fiscal reforms, market reforms, labor reforms. You can have all sorts of new incentives for killer products, but if your businesses are locked into Germany into a second industrial revolution platform infrastructure, centralized telecommunication, fossil fuel nuclear power, internal combustion road, rail, water, and air transport on dumb systems, you're never going to get beyond the ceiling of 18.5% aggregate efficiency. You're stalled. And on that first day, I outlined a third industrial revolution for the Chancellor, a new conversion of communication, energy, and transport. And at the end of the day, she said to me, Mr. Rifkin, I like this third industrial revolution. We will have this for Germany. I'll come back in a few minutes and report on where we are all these years later.